Hi, I'm Beth Wilson.
And I'm Marty Kelsey.
And this is STEM in 30. What's our topic, Marty?
This is your show. I planned the last one.
Wait a minute. That sounds like breaking news from Nick Partridge. Let's see what he has to say.
Ladies and gentlemen, we interrupt your regularly scheduled STEM in 30 program to bring you this special report. I'm standing here live in front of the Phoebe Waterman Haas Public Observatory in Washington, D.C., where about 20 minutes ago, astronomy educator Shauna Edson reported observing several large explosions of incandescent gas on the surface of Mars. The spectroscope indicates that the gas is hydrogen and is headed towards Earth at enormous velocity. Edson reported the phenomenon as, quote, like a jet of blue flame shot from a gun, end quote. It is our belief that Martians have launched ships towards Earth to begin an invasion. One thing is certain, there is no stopping them. Let's go to footage now from NASA.
Stop! That's not Mars invading Earth. This is Earth invading Mars. Where are Beth and Marty? We've got to get this right. Beth, Marty, there seems to be a lot of confusion out there about Mars. I think we could straighten it out.
I think we found our topic.
Do you have time?
We have about 30 minutes.
I'm new here. Why 30 minutes?
Well, because
This is STEM in 30. This is STEM in 30.
Hi, and now we're coming to you live from the National Air and Space Museum in the Exploring the Planets Gallery.
And this gallery really does show that if you set your mind to it, you can accomplish anything.
Well,
let's go look around.
Take a look.
Here in the Exploring the Planets Gallery, you can discover the planets, moons, asteroids, dwarf planets, and comets in our solar system, and learn about the spacecraft that travel great distances to study them.
In this gallery, you'll find 3 generations of Mars rovers, as well as the Stardust capsule, which was the first to bring back a sample from a comet.
There's also the Blink Comparator, which Clyde Tombaugh used to discover Pluto in 1930.
Of course, there's also a full-scale model of the New Horizons spacecraft, which in 2015 showed us the heart of Pluto. But today we're not talking about Pluto. That's for another show. Today we're talking about Mars.
Well, before we get started, let's welcome our students today, Whittier Education Campus. Thank you guys so much for coming in. We can't wait to hear your questions later in the show.
And we'd also like to welcome our online viewers and our viewers on NASA TV. You can submit live questions and perhaps we'll answer them during the show.
We have an expert standing by to answer them if you submit them online as well.
Okay, so what we have first today is some students who have got a big question for us. So let's take a listen to their question.
Hi, I'm Stephanie May from South Valley Middle School in Liberty, Missouri.
And we are wanting to know, why is there such a fascination with Mars?
Well, we're going to spend the next 30 minutes talking about why there's a fascination with Mars. But right now I'm joined by Dr. John Grant, one of the scientists here at the museum. Thank you for joining us.
My pleasure. Hi, guys.
John, what got you interested in Mars?
When I grew up in northern New York State, I looked out around me and I saw lakes and I saw rivers. And when I was a teenager, the Viking landers landed on Mars. And lo and behold, I saw dry lakes and dry rivers in terms of the images. And it really made me think about the possibility that there could have been life on Mars.
Now, part of your job is working with Mars Rover, so you get to drive these things and go out and discover things. So do you sit in your office with, you know, like a game console where you turn it and push the gas and move it around?
I wish, but it turns out that you can't drive a rover on Mars that way for a couple reasons. One, you want to make sure you don't drive into something, but really because Mars is so far away that it takes a long time for the signal to get from Earth to Mars and back. So there's a delay. You wouldn't really be able to do things in real time because you wouldn't be able to see where you went.
Now, if one of the rovers is driving along and let's say there's a hole, does it just fall into the hole?
No, what we do through the rover planners out of the Jet Propulsion Lab is plan what we call keep-out zones. Things that are hazards, things that are outside the bounds of where we want to go are considered off limits. But then the rover also has sort of hazard avoidance things. So if there's something that pops up unexpectedly, which has never happened, it would know not to drive off a cliff.
Well, we have some friends who are actually trying to program some robots. Do you want to see how they're doing?
I'm curious if they do better than we do.
Okay, let's take a look.
All right, so we've got a couple of friends here, and they're getting ready to drive some spheroid rovers. Now, the way that these work is you plot a course for them on the iPad, and you hit go. And so you've got to kind of pre-plot your course. Now, we've got a couple of craters over here. I want to see if you guys can end up in one of those craters. Give it a try. Keep going, see if you can hit that, hit the mark there. Well, you guys are, that was really, you did it. Great job. Nice work. I will tell you guys, I am tremendously bad at this. So you guys did a much, much better job. Beth, these guys are on a roll. Let's go back over to you and John.
What do you think they could be your next Mars rover
so,
drivers?
No, I couldn't do that.
It looked a little harder than one might expect, though.
Exactly. I think it's kind of complicated.
Yeah, well, they have another rover that they're trying out over there. This one's got a little camera. Shall we go back and see
Sure,
if
let's see how they
this
do
is
with that.
better?
All right, so we've got another friend here, and he's going to drive this one. Now, hold on. You're getting real anxious here. Now, we've got this rover, and it's got a camera on it, but just looking at the terrain here, that's too easy, and not like what we do on Mars. So what we're going to do is we're going to turn you around. Now, we've got kind of a target out here we want you to try to find. So see if you can drive that rover without actually looking where you're going other than the camera on board. So what's going on? It looks like you're up against some mountains there. I like how you're taking the small steps there. It's not quite as easy as it looks, is it? What's hard about it?
Just looking at the camera and turning.
All right, well, Beth, we're driving. You don't need any roads, so let's go back over to you.
Yeah, they don't need any roads, but they might need some work with driving that rover around. Even that's a little more difficult.
I think that's right, but it is a little bit like the way we drive the rovers on Mars, where we drive a ways, take some pictures, and then create essentially a landscape that we drive into the next day.
Well, are you ready for some questions?
Sure.
Let's start with a video question.
Okay.
My name is Michaela, and my question is, when did the first robot arrive on Mars?
What was the first robot on Mars?
Well, the first robot that landed on the surface successfully and operated were the Viking landers back in 1976. And as I said earlier, that's kind of the thing that got me piqued my interest in planetary geology.
So we've been on Mars for a while.
Yes, we have.
Well, let's try an online question. Let's see. Are there places on Mars where the rovers can't go?
There's two kinds of places the rover can't go. One has to do with hazards. If the hill is too steep, if the rocks are too big, we can't go to those places. The other kind of place we can't go is where there might be life on Mars. We don't know if there's life on Mars, but there's places where if there is, it's likely to occur. Places where there might be liquid water today. So those are sort of steer clear places as well.
Okay, I think we have a student who has a really great question about taking pictures. Come on up.
Is there a scientific reason for the rover to take selfies?
There is. The rovers take selfies for two reasons. One, because usually we've just drilled a hole in the rocks and it allows us to provide context for where the drill hole is, the things around it, and where the rover was sitting. The other time that we take selfies is to understand what's happening with the rover, to look down, for example, on Opportunity and see how much dust is accumulated on the solar panels. So there's both operational and scientific reasons.
It's not just for their Facebook page.
No, it's not just for their Facebook
Okay.
page.
And we have another video question.
Okay.
Hi, my name is Michaela, and my question is, why is it important that we found water on Mars?
Why is it important that we found water on Mars?
Well, I started to say this a little bit earlier and then I lost my train of thought, but really water is something on the Earth that we associate with life. Where we find water, we find life. And so the idea is that on Mars, if we've got liquid water, then potentially that relationship holds true, because water is the key to many of the kinds of things that life needs to get going.
Well, we were able to talk to some astronauts and we got their thoughts on Mars. So do you want to take a look at what they had to say?
I would love to.
Let's see.
Well, you're looking for the signature of life, because you know there's not going to be somebody standing up going, "Hi, welcome to Mars." So you're looking for things like carbon dioxide that we breathe out, or if it's an anaerobic system, one without oxygen, you might get sulfur dioxide or sulfur-based compounds. There are a number of different things that you could be looking for, and you have to hone in on what's there and then refine it. So it's an iterative process, like most sciences.
Well, I was there in space for about 6 months, 5.5 months, and my skeleton, lost a lot of weight. My muscles change, my eyes change, my way of perceiving things change, and so we need to understand all this mechanism, the impacts that we have on our body, and we need to make sure that we have the capability of preserving the body, the functionality of the body over this long period of time, which is 2 to 3 years.
We're looking at ways to provide astronauts with autonomy. If I call the ground from the International Space Station, I get an immediate response. But if I'm traveling and I'm near the Martian surface, it's going to take a long time to get that response. So astronauts and the ground team that support them are going to need to figure out how to deal with those type of psychological issues.
Say there's two big challenges. One is the transportation to get there, and then the second has to do with health. When you look at transportation, now we're going 30 million to 250 million miles away, depending on how the planets are aligned. It's a long time to get there. It's a big distance, so we need a vehicle that can get us there. When you talk about health, how are we going to react being in space for that long with the radiation problem? And then we have food, water, all those things that we take for granted here.
Well, we astronauts in space are guinea pigs in a certain way, and one of the ways that we help in planning the Mars mission is allowing the scientists to look at our body and see what happens when you stay in microgravity for a long time.
Right now we have Scott Kelly up there for an entire year because we need to push beyond 6 months if we're going to send someone to Mars. And then what's going on with our machinery? How's the reliability? How's our environmental control system? Is it keeping us alive? Is it breaking down? Do we need to supply spare parts? Now we're even looking at 3D printing, which I think is going to have a great application to go to Mars. And so all of it together, it's everything together. It's the human living, it's the scientific research, it's the machinery and the reliability.
Whether it be recycling their urine into drinking water or finding ways to break down water into hydrogen to give them, and oxygen to give them breathing material, and how to grow plants in space so that perhaps they can eat their salads that they grow in the spaceship. So it's really important for people to be focusing on the future with recycling capability and ways to eliminate the need to carry big, massive things into space.
We're joined now by Matt Schindel. You are a curator here at the National Air and Space Museum, and we've been fascinated with Mars for a long time. Why such a fascination with the red planet?
Well, I think there's at least two questions to that. Why have we always remained so interested in Mars? The first, I think, is that Mars has done a really good job of holding on to its secrets. And the other is that during the time that we've been observing it, our idea of what Mars is has shifted dramatically at least twice, probably more than that. Keep in mind that the earliest observations of Mars were done just with the naked eye. And they were also done during a time when we didn't even really have a concept that the Earth and Mars orbited the sun. So the motions of Mars in the night sky, this sort of star that seemed to move, were mysterious to the early observers. Now, in the age of the telescope, that started to change. Galileo looked at Mars through his telescope in 1610, and from then up until the mid-19th century, astronomers kept looking through bigger and better telescopes and even began mapping the surface of Mars. There was one main problem, though, during that time, which was that when you're looking at Mars from the Earth, you have to look through the Earth's atmosphere, and that makes Mars look blurry, pretty much no matter how good your telescope is. Now, we're in the 19th century, so the biggest sort of promoter of the idea that Mars was an interesting place, that it might be the abode of life, was an astronomer named Percival Lowell, who came from a very wealthy, very prominent Bostonian family. And Lowell decided that he was going to build an observatory in Flagstaff, Arizona, where he thought the altitude was high enough and the atmosphere would be thin enough that he could finally get a clear look at what the surface of Mars looked like. And what we have here is a globe that Lowell had made in 1905, showing what he saw, or thought he saw, through the telescope while looking at Mars. And you can see it's a system of canals. And what Lowell thought he was seeing here was evidence of extraterrestrial intelligent life. Basically, a civilization that was dealing with an ecological crisis and trying to keep their planet alive through huge feats of engineering. So Lowell's vision of Mars sparked a lot of interest in the human imagination, but unfortunately he wasn't really seeing this. And we have an image from Mariner 4. In 1965, NASA sent Mariner 4 to fly by Mars, and what it sent back were these pictures of a very desolate-looking Mars, heavily cratered like our Earth, and really looking like it might not even be that scientifically interesting. But then we sent Mariner 9 in 1971, and Mariner 9 went into orbit around Mars. It mapped the surface of Mars photographically, and as you can see, it sent back pictures of much more interesting Mars. In fact, when Mariner 9 first arrived at Mars, the whole planet was covered in a planet-wide dust storm, and they couldn't see anything. But as the dust storm slowly subsided, it revealed huge volcanoes, the largest volcano in the solar system, Olympus Mons, and also a very huge canyon system that's about as wide as the entire United States of America, Valles Marineris. So Mars was once again a very dynamic planet, but it was very different from Lowell's version of Mars, right? It was no longer as mysterious, but it was now sort of a puzzle with its own geologic history, and we've been trying to unlock that ever since.
Awesome. Well, you ready to take a couple of questions?
Sure.
All right, we've got a friend at South Valley Middle School that's given us a question.
My name is Julia, and my question is, why are so many of the science fiction books based off of Mars?
Well, I think the answer really lies, at least in part, with Lowell and that story I was just telling you, that the human imagination was really sparked by the idea that there could be life on Mars, that there could be another intelligent civilization nearby, and that we could somehow, someday, interact with that civilization. So H.G. Wells in his War of the Worlds, Ray Bradbury in his Martian Chronicles, both of these authors in their works used this idea of an ancient Martian civilization that we might one day have to deal with in some way.
Cool. All right, we've got an online question next. Do you think Mars will ever be colonized?
That's a very difficult question to answer, and the truth is that Mars is incredibly inhospitable, and it would take a great deal of resources to make it hospitable, to terraform it. So if we ever do colonize it, it would be in a very limited way, probably in some kind of self-contained environment.
Okay, we've got an audience question next.
What is your favorite Mars sci-fi?
I think for this time of year, because it's October and Halloween is coming up, Ray Bradbury's Martian Chronicles is probably my favorite piece of Martian sci-fi. It even includes a sort of retelling of Edgar Allan Poe's Fall of the House of Usher using robots and a mechanical haunted house. So for this season, that would definitely be my choice.
Awesome. Well, thank you so much for talking with us about our fascination with Mars throughout history. But let's go back over to Beth and John and learn more about Mars today.
Great.
So John, where are all of these robots that we've put on Mars?
Well, the ones that have landed on Mars are in different locations depending on what the goal of the mission was. The map that you see here shows, for example, where our rovers are, Opportunity and Spirit, the Mars exploration rovers, that were really going after understanding the role of water in shaping the surface of Mars. Curiosity is kind of between the two, and it's the sort of big sister, if you will, that's really going after the question of whether Mars might have been habitable.
Now, what did Spirit and Opportunity find that was particularly interesting?
Well, starting with Spirit, we landed in a place called Gusev Crater, and after driving for a while, discovered these layered rocks that also show hints through their chemistry and their form that they were actually in place during a volcanic eruption through sediments that were, at least for a time, wet.
And how long have these been running?
They've been running a long time. For example, Spirit was going for a long time, such that one of the 6 wheels stopped working and we were dragging it. And that turned out to be sort of a lemonade out of lemon situation, where, as you can see from this bright white streak here, as the wheel was scraping across the surface, getting the dust out of the way, we found this material called silica. And that silica was in place in a steam vent, or maybe even some sort of fumarole around a volcanic center like I showed you before, and tells us that this place might have been once like a miniature sort of Yellowstone. Hot, but wet, and perhaps maybe habitable.
And is Opportunity still running?
Opportunity, after 11.5+ years, is still cranking along. Here's a view looking back. You can see our tracks fading in the distance as we've been driving along the rim of a very large crater called Endeavour Crater, trying to understand the ancient geology of Mars.
Now, how long were they supposed to run?
They were supposed to last about 3 months, 90 sols, which is just a little bit longer than 90 Earth days. But as you can see, we've been traversing very incredible terrain. This is still on the rim of Endeavour Crater. This is a place called Marathon Valley. And if you look carefully, you can see color variations within the valley that we think are somehow related to occurrence of clay that we see from orbit, that tells us that water was here for an extended period, and that water existed in a form that wasn't too acidic, wasn't too basic, but maybe just right, and might be, again, representing these sort of habitable conditions early in Mars history.
And Curiosity's doing something different.
Curiosity's building on the results of the Mars exploration rovers and really going after habitability. For example, what you see here in this slide are a bunch of layered rocks that are sedimentary rocks that, in this case, we know now through exploration were deposited as water drained down the wall of the large crater, Gale Crater, that we were in, and deposited them as sediments flowing into a lake. And the layered rocks that you see here now, we're currently exploring and trying to understand what they represent about a change of environment from that early lake environment within Gale Crater.
Shall we take some questions?
Let's do.
Let's take some questions.
My name's Riley, and my question is, why is Mars red?
Why is Mars red?
Mars is red because it's rusting. I grew up in northern New York. It snowed a lot, and they used to put salt on the roads, and my car would rust. And the same thing is happening to the iron minerals in the rocks on Mars. They're rusting, and that's what gives it its reddish color.
And we have an online question. How long does it take to travel to Mars?
It takes months, and even when Mars is as close to the Earth as it can be, as we heard from our astronauts earlier, this is not a trip that is for the faint of heart or for the impatient. It's a long, long ways away, tens of millions of miles, and it takes anywhere from 6 to perhaps 9 or 10 months.
And we have, one of our audience members has a question for you.
My name is Roshonda, and my question is, how do you know what rocks on Mars are made of?
How do you know what rocks on Mars are made of?
We do a couple of different things. We actually analyze the rocks directly to understand what's within them. We take samples with Curiosity and do that. But we also do it through something called remote sensing, where we use cameras and other instruments that look at different wavelengths of light and can tell how the different compositions reflect light differently. Just like my hand is a different color than this wood, there's information there about what those different things are made of.
Let's take another video question.
My name is Destiny, and my question is, how long is a day on Mars?
How long is a day on Mars?
Well, at first glance, it's about the same as an Earth day, but it's actually about 40 minutes longer, and that really messes with you when you're trying to work on Mars time.
Do you work on Mars time?
We used to work on Mars time. When these missions first started operating on the surface, for about 3 or 4 months we did. But the problem is, about every 2 weeks, you actually go through a whole cycle of an Earth day. So you might start on the first day of the mission at 8 a.m. in the morning, but a week later you're at 8 p.m. at night.
That doesn't sound like a lot of fun.
It's not a lot of fun because it's not like getting on a plane and getting off 6 hours later and being jet lagged. It changes every single day.
Well, We are doing research to get us to Mars, and we visited NASA headquarters where they have something really cool that we should take a look at.
Let's do.
I'm here at NASA headquarters, and I'm joined by Marshall Porterfield. Now, we're standing in front of Veggie, the vegetable production system. Can you tell me about this?
This is a demonstration unit, a mock-up of the exact hardware system that's operational right now on the International Space Station. We're using it right now to demonstrate our ability to grow plants in space and also produce vegetable crops which can be used to feed the crew.
Now, the light in here is very weird looking. Why is that?
Well, this is an example of efficiency for spaceflight hardware. So we're using red and blue light to feed photosynthetic light to the plants, and it's designed to very precisely feed the wavelengths of light that the plants require for photosynthesis only, as opposed to white light, which would include green wavelengths, which would just simply bounce off, be reflected back off the plant. So it's an example of electrical efficiency and photosynthesis.
So that's why the plants in there look kind of dull rather than the bright green that we're used to when we see plants.
That's
Really?
right. There's no green photons being wasted.
Awesome. Now, how is this a step towards a future trip to Mars?
Well, we really wanted to demonstrate our ability to grow vegetable crops. We wanted to also demonstrate that the plants that we do produce are healthy and are free of pathogens in a spaceflight environment. This demonstrates our ability to be able to grow those types of crops, which are going to be very important in long-duration human missions, not only for the plants to produce nutritious food, help recycle the atmosphere, absorb CO2 and produce oxygen, but also for the psychological comfort of having a piece of home. We recently grew a crop of lettuce on the International Space Station, and we provided the crew with a little bit of vinaigrette salad dressing, and they say that they enjoyed that experience quite a bit.
Awesome. Well, thank you so much for talking with us.
No problem.
Well, it looks like we still have a lot of work before we get to Mars.
But we are headed in the right direction.
Maybe they'll make it. Maybe we'll see some
Maybe
of
they will make it.
our friends up there. Thank you so much for telling us about your work on researching Mars.
Thank you, Beth, for having me.
Now, next month on November 18th, we will be looking at 15 years on the International Space Station. Check this out.
Check this out! That's Buzz Lightyear, but not any Buzz Lightyear. This guy spent 15 months aboard the International Space Station, 250 miles up. And he didn't just go along for the ride. He was up there helping with microgravity experiments. This guy's on display at the Moving Beyond Earth Gallery at the National Air and Space Museum in Washington, D.C. And if you think this is interesting, be sure to check out STEM in 30.
Well, we want to thank everybody for watching today, and we want to thank NASA for sponsoring us, and we want to thank our friends here. You all give yourself a round of applause. We'll see you next month. So this whole, did JPL put their initials on the